In this video, we're going to look at another 5 examples on how to simplify algebraic expressions. So let's start with number 1. The first thing we should start beginning to realize with questions like number 1 is that there is more than one term. In the examples that we did in the previous video, those questions typically only had one term. When you have two terms, and the reason we know that is that we've got a minus separating the two terms, and here we've got another minus separating the two terms, then we cannot simplify or we cannot cancel vertically. So for example, something I often see students try and do is they would try and cancel these two, for example, this 5x and this 5x. However, that doesn't work, due to the fact that we have more than one term at the top and more than one term at the bottom. So what we have to do is go from having two terms at the top to having one term and the same at the bottom. How do we do that? The key thing is to factorize. That is very important. If you can just factorize, then you will be able to transform something from having two terms to only having one term. There were negatives in the previous videos as well, but those took on a slightly different form. They usually looked something like this. They looked something like that. So yes, there is a negative, but there's a multiplication sign in between these two terms. Whereas with this one, that isn't the case. There's no multiplication in between the two terms. All right, and the same at the bottom. And so let's start with factorizing. So what I'm going to do is I'm going to look at the top half of this question and then the bottom half separately so that you can clearly see what's happening. So if we look at the top half, it doesn't appear that there's a common factor just yet because this has a 5 to the power of 2x, whereas this is a 5 to the power of x. But what we can do is know that 5 to the 2x is the same as 5 to the x times 5 to the x. That's true because remember, when the bases are the same, what do you do with the exponents? You add them, and x plus x is 2x. Then I'm going to say minus 3 times 5x, and here we can see that in these two terms there's now a common factor of 5x and 5x. And so in the next line, I will factorize that 5x out in the front, open up a bracket, and then have a look what's left over. So in the first term, we have a 5x left over. In the second term, we have the 3 that is left over. Okay, so that will be the top half of this original question factorized. I'm now going to look at the bottom half and factorize that as far as possible. And so now we're going to look at the bottom half. So in the bottom half, we can see that there's definitely two terms. That's one term, and that's a second term. What we can see that there's a 5x in the first term as well as a 5x in the second term. And so we can take that out as a common factor. Furthermore, there's also a 2 in the first term, and we could definitely break this 6 up so that it also has a 2. I'll show you how to do that. And so I'm going to break this 6 up into 2 times by 3 times by the 5x. And so now we can circle all of our common factors. So there's a 2 and a 2 and a 5x and a 5x. And so we will take that out into the front. So it's 2 times by 5x. Open a bracket. Let's see what we have in the first term left over. Well, in the first term, we've got the 5x that is left over. That's this one over here. Minus, and then we have this 3 left over there. So now we have factorized the top half and the bottom half. In the next step, I will put those two halves into one sum. Now, if we look at this resulting expression, we can see that at the top we have one term and at the bottom we have one term. Many people ask me, but surely inside here there's two terms. Yes, that is correct. But if you look at the expression as a whole, so this whole thing over there, it's classified as one term because it's separated with a multiplication. And so we have one term at the top, one term at the bottom, so now we can cancel vertically. So we can see that these two are going to cancel because they're the same. These two are going to cancel because they are the same. And so all that we have left is a 2 at the bottom. But now we obviously can never write an answer like that. So if there's nothing at the top, then we will simply put a 1. And so the answer to that one is a half. Moving on to number 2, what we can now see is that we have a question where we have one term over one term. And so we can simply combine everything together. However, a mistake that I mentioned in the previous video is that people often try to combine the 45 and the 5 together and then multiply them. But remember, that only works when there's no exponents involved. When there are exponents involved, you can only combine things that have the same base. And so at the moment, none of these have the same base. So what we do, remember, is we have to drop each of those numbers into their prime numbers, and that's where the Casio allows you to do it by using that shift fact option. And so let's go and switch each of those numbers into their prime factors. So the number 45, we know that if you do it on the calculator, is going to be 3 squared times by 5, and then you put that in a bracket, and then you write the exponent that was there, which is 1 minus n. 5 already is broken down as far as it can be, so you just leave it like that. The number 4 is the same as 2 to the power of 2 in brackets, n plus 2. The number 36 is the same as 2 squared times by 3 squared in a bracket with the original exponents minus n minus 1. Then what we do is we want to get rid of all the brackets. So remember, over here you take this 1 minus n, and what do you do with that 1 minus n and these, the exponent 2 and the exponent 1? You multiply, remember? So that's going to give us 3 to the power of 2 minus 2n. Remember that 2, that is the exponent of the 3, must multiply to the 1 and the n. Then we're going to do the same with the 5, and so that's just going to be 1 minus n. Then I'm going to write this 5n minus 1 next to it. Nothing changes there. Now we're moving to the bottom, where we need to multiply this 2 with this n plus 2. So that's going to give us 2 to the power of 2n plus 4. And now we need to look at this 2 and this minus n minus 1, which is going to give us 2 to the power of minus 2n minus 2. And then the 3 will be 3 to the power of minus 2n minus 2. Now what we can do is look at the top and then look at the bottom separately and combine any terms that are the same. So for example, at the top we have a 5 as the base and a 5 as the base over there, and so we can simply add those exponents together, but we keep it as a 5. We'll never say 25. So we'll leave that 3 to the 2 minus 2n as it is, 5, and then we'll say 1 minus n plus n minus 1. So all I did is I added these exponents together. We'll then look at the bottom, where we've got these 2's, which are the same. So it will be 2 to the power of 2n plus 4 minus 2n minus 2. So you see, all I did is I added these exponents together, and then we've got the 3 as minus 2n minus 2. And so now I'm just going to go simplify each term. So the 2 minus 2n at the top, for the 3 that stays the same. For the 5, we're going to have everything cancels out. The n's will cancel, the 1's will cancel, and so we'll end up with 0. For the 2's, we're going to end up with a 2 to the power of 2, because the n's would cancel over there, and then you'd be left with 4 minus 2. And then the 3's, we can't really simplify anything there, so I'll just write it as it is. Alright, now next we have 5 to the power of 0. That is just equal to 1, so we'll change that to 1. And then the 3's over here, they have the same base. But because the 1 is at the top and the 1 is at the bottom, can you remember what we do with the exponents? We minus. It's always the top exponent minus the bottom exponent. And then please remember, when you're minusing, you have to be very careful, because minuses or negative signs, they can change the sign when you are minusing. So what I mean by that is the following. So for that 3, we have 2 minus 2n. Then we're going to minus whatever's at the bottom, and that's the minus 2n minus 2. Notice I've put it in a bracket because this minus over here is going to be able to go into each of those terms and it will change the sign. Then we said that 5 to the 0 is just 1. And then the 2 to the 2 at the bottom, well, we can just write that as 4. And so working on the 3, it's going to be 2 minus 2n plus 2n plus 2 times by 1. I'm not even going to put the times by 1 there because that's not necessary, over 4. And now we can simplify, so the minus 2n and the plus 2n cancels. 2 plus 2 is 4, so it'll be 3 to the power of 4 over 4. And 3 to the power of 4 is 81 over 4. And then you can leave the answer like that. Moving on to number 3, it's a relatively short question. So we've got this 2 on the outside, and so that 2 will multiply with that 3. And then the number 2 at the bottom, if you don't want to think of it as 2 to the power of 2, you can remember that this 2 currently has an exponent of 1. And so the exponent rules say that that 2, the exponent 2 will multiply with that 1 over there. And so what we're going to end up with is a to the power of 6 over 2 to the power of 2, which can be simplified as a to the power of 6 over 4. Moving on to number 4. Here we can see straight away that we have got a question which has more than one term. So at the bottom we have one term, but at the top there's 2 terms. And so because of that we cannot combine the top part and the bottom part yet. So what I'm going to do is I'm going to show you how to simplify the top part first. Now remember what we said. We said that if you have 2 terms, then to get from 2 terms to 1 term, typically you're going to have to use factorization. So let's take a closer look at what's going to happen at the top term. And so I've written the top half of the fraction over here on the right. So that's this part here. And so now we're going to see how to factorize this. So remember in number 1 of this video, so this one over here, when we had 5 to the 2x, we broke that up as far as possible. So we broke it up into 5 to the x and 5 to the x. So this part here can break up into 2 to the power of x times by 2 to the power of minus 3. The reason that that is true is when these bases are the same, what would you do at the exponents? You would have added them, and so that would have given you 2 to the power of x minus 3. So we're just doing it in the reverse order this time, just to separate things a little bit. Then I'm going to say minus 3 times by 2 to the power of x times by 2 to the power of minus 1. So I just split that part as well. And now we simply go look for common factors. And so I see a 2 to the power of x over here, and a 2 to the power of x over there. And so we can take that out in the front, and then we can open up some brackets and see what we have left over. So we've got this 2 to the minus 3 minus, and then we've got a 3, and we've got a 2 to the minus 1 left over. And so if we have to simplify that, that'll be 2 to the power of x, and then this part in the bracket, 2 to the power of minus 3 is the same as 1 over 2 to the power of 3 minus 3, and then 2 to the power of minus 1 is the same as 1 over 2, and so you can just put it under the 3 like that, and then that's going to give you 2 to the power of x and 1 over 8 minus 3 over 2. Now here you could do the whole common denominator thing, or you could just type it in the calculator, and that's going to give you a value of negative 11 over 8. And so I'm now going to take this whole expression and put it back into the original sum. And so what we need to still do is just break up the bottom part a little bit. And so that bottom part could be broken up as 2 to the power of x times by 2 to the power of minus 2. Now we have one term at the top, one term at the bottom, and so we can cancel. And so this we can see cancels with each other. And so what we have is minus 11 over 8 over 2 to the minus 2. And then 2 to the minus 2 is the same as 1 over 2 to the 2. I'm just going to write the rest over here. And so that's minus 11 over 8 over 2 to the 2 is 1 over, or 2 to the 2 is 4, so I'm just going to say 1 over 4. And now what we have is we have a fraction. And by the way, there are other ways of doing this sum, so you don't have to do it this way. You just want to make sure you get the same answer at the end. So if you've done this differently, absolutely fine. And we have a fraction on top of a fraction, and so the way to treat that mathematically is to say times, and then you flip the bottom fraction over, so it becomes 4 over 1. I'm then going to cross cancel the 4 and the 8, so 4 goes into there once, 4 goes into there twice, and so you simply end up with minus 11 over 2 as your final answer. We're now going to look at the last question of this video, number 5. With number 5, we are going to be looking at something new, so that's now we have square roots. And so there's a specific way that you can simplify square roots. And so what you want to do, and there's two ways of doing this. And so for this video, I'm going to show you both ways, and then going into future videos, you can choose whichever method you would like. And so I'm going to start off with method number 1. Method number 1, you're going to look at that 12, and you're going to try break down that 12 into the combination of, or you want to try get at least one square number. Now a square number is something like 4, 9, 16, 25, 36. It's all of those numbers. So 12 is the same as 4 times 3. Okay, so we haven't changed the sum. We've just written 12 in a different way. X to the power of 6. In the next one, the 3 is already as simplified as possible, and so we'll leave it just like that. Then what we do is we take the square root. So what is the square root of 4? Well, that's a 2. And what is the square root of x, 6? Remember the way square roots work, because it's always the inside exponent divided by the outside exponent, and so that'll be x to the power of 3. And so those two expressions are now going to be on the outside of the square root, and the 3 will stay on the inside, because we don't know what the square root of 3 is. Of course, you could type it in on the calculator, but we're simplifying over here. Then for the next one, we've got the minus 4 that is already on the outside. The square root of 3 we don't know. The square root of x6 becomes x to the power of 3, and so we have a 3 left over on the inside. So now what we have is 2x3 to the square root 3 minus 4x3 square root 3. So the way you could picture this if you want is to think of it like this. So we've got 2 of those minus 4 of those. And so 2 minus 4 is minus 2. So we'll have minus 2 x3 square root 3. Moving on to method number 2. So we'll come back to this original starting point. You can type the 12. You know how in the previous videos we did the shift fact, or we also did it in this video, shift fact. So you do that with the number 12, and what that's going to give you is 2 squared times 3. And then you just write the x6 minus 4. Now if you had to do the shift fact with the number 3, you're just going to get 3 anyways. Then what we do is we see that we now have an exponent over here, and we know that there's a number 2 on the outside, and so the rules of exponents say that you should take the inside number and divide it by the outside number. And so we're going to get 2 to the power of 2 divided by 2, which is 1. And then this x6 once again becomes x to the power of 3. And then we don't know what the square root of 3 is, and so we leave it like that. Then, as with the previous method, this x6 is just going to become an x3, and then we're going to be left with a square root 3. And then we're back at the original steps that we had in the previous question, and so this answer will also equal minus 2x3 square root 3. So method number 2 seems a bit easier because you just type it in on the calculator and it will break the numbers down for you. With method number 1, you would have to know which numbers to choose. And so, yeah, so with that number 12, you would have had to have chosen a number that is a perfect square. The reason it has to be a perfect square is so that you can take it out of the square root eventually. And so that's the end of this video. In the next video, we'll look at another set of examples.